Hi, and welcome to this first video from the algebra section. Now, the first thing we've got to deal with is that question, algebra. Why bother? It may be that you've not seen a lot of algebra so far at school, but trust me, there's a lot more coming later. And algebra is just to do with using letters to describe particular numbers, which sounds a little bit weird. But the answer to the question, why do we bother? It makes life a whole lot easier if we can describe relationships and the world around us using mathematical formulae and letters, rather than sometimes writing the whole thing out in words. And if I can just give you a couple of examples. Let's say we're looking at a rectangle, and the statement says, I can find the perimeter of a rectangle by taking two lots of the longer side, then adding on two lots of the shorter side. And that's a rule that will help me work out the perimeter, i.e. all the way around the outside of a rectangle. Now, for me, if you take that and look at how big that statement is, and then say, well, let's do it algebraically. Let's use letters to replace some of the words and kind of to represent numbers in this equation, in this formula. What you get is that. So we can say, okay, if that's the length, which we're going to call L, that's the width, which we're going to call W. So two lots of the length plus two lots of the width, and all of a sudden this great big long statement here becomes a nice simple sum that we can do. Another example would be something called Pythagoras' theorem, and your teachers may or may not have mentioned this one. This is something that you're going to be spending a lot of time doing when you get to senior school. But if you haven't heard of it, do not worry at all. It's basically that. Pythagoras, which is an ancient old Greek mathematician from about 2,500 years ago, came up with this idea. He said for any right-angled triangle, he said the square and the hypotenuse equal to the sum of the squares on the two shorter sides. Which seems like a bit of a mouthful. But there we go. If we take our triangle, just call that one A, that one B, that one C. The square of A plus the square of B, so it's the square on the two shorter sides, is the square on the longer side, which is called the hypotenuse, which is that one there. So A squared plus B squared equals C squared. And again, if you look at what we had to say in terms of the orange statement here, written in words, compared to what we've got when we write it algebraically, you can see this one much more short, much more simple than that one. And so that's kind of basically why algebra is a really, really useful thing. And let's say as you get further up through school, when you get towards kind of GCSEs and possibly beyond, you'll find a lot of your maths works and a considerable amount of what you do in science as well. You use formulas and algebra to describe these relationships. So let's say it is well worth taking the time to get good at the basic ideas right now. Right, so that was a bit of an introduction to kind of why we'd need algebra. Let's just have a look at something that you might have to do in your test. So here we go. So what we're going to do to begin with is look at how we can use expressions and formulae like the ones we saw on the previous slide to help us do some calculations. So here we go. So there is our formula for the perimeter of a rectangle. So we're going to work out the perimeter, i.e. all the way round the outside. There we go. And we're told that one there is the length, L, and that one there is the width, which is W. So let's say now we've got a rectangle which has got a length of 6 and a width of 8, and we want to find the perimeter. So what I'm going to do is take my formula from here, there it is, and I'm just going to say, well, if L is worth 6, I'm just going to plug that in there. W is worth 8, I'm going to stick that in there instead. So essentially, all we're doing is just replacing the letters with the numbers. So let's do that now. So let's put in some numbers. So instead of the L, I've got a 6. Instead of the W, I've got an 8. And here we've got to be a bit careful if we have a look at what she's saying there. When I've got letters, I don't need the time signs because the time signs look a little bit like letters. They look like X's. Whereas when I put in numbers, I need the time sign because if imagine that time sign wasn't there, all of a sudden that would look like 26. And it's not 26 at all. It's 2 times 6. So when you've got letters, you don't need the timeses. When you've got numbers in there, you absolutely do. And then all we've got to do now is think a little bit about our BODMAS. Remember the order in which we do things. And if I'm going to work out the answer to this sum here, I'm thinking, what am I going to do first? Have I got to do the timesing or the adding? Let's go down here. Multiply. There it is. The M comes before the A for add. So we'll do the multiplying first. So 2 times 6, which is 12. 2 times 8, which is 16. So now we've got 12 plus 16. There you go. So my perimeter is 28. So two things. We've firstly got how we're going to put these numbers into our formula. And then secondly, thinking about our number skills from previous videos on how to work out that, so making sure we're getting all our operations in the right order. Okay, so on we go to the second one. Exactly the same formula. Now we've got these numbers, so we're going to say it's a different rectangle. So our rectangle now has got length 4.3 and width 1.7. So again, exactly the same principle. Plug the numbers in, making sure we remember our time signs. Now do the working out, doing our multiplications first. So there we go. And then finally add them together, and we've got the answer. Okay, so on we go, and let's have a look at some more expressions. So these ones look a little bit more complicated, but the principles are exactly the same as what we looked at from the last slide. And of course, we've got a whole world of BODMAS that we've got to be thinking about as well. So here we go. First one, so we've got three lots of all that stuff inside the brackets. So the first thing we're going to do is take our numbers, m is 7 and n is worth 2, and put those in. So let's do that. There we go. Again, remembering our time signs. So now what we've got to do is think about how we're going to do these. So we've got to work out B for brackets comes first. So we've got to figure out how much we've got inside the brackets. Now, as soon as we get inside these brackets, we're thinking, okay, am I doing the timesing first or the taking away? And it's going to be the timesing. So inside the brackets, I've got 14, 2 times 7, take away 6. 14 minus 6 is 8. So I've worked out what I've got inside my brackets. And then the last thing to do is multiply out the brackets. We've got 3 times 8. And there you go, answer's 24. On we go to the next one. Here it is, 4p squared minus 5q. Remember, squared, where's my mouse gone? There it is. Squared just means times by itself. So here we go, let's put in the numbers. So we've got 4 times 5 squared minus 5 times 4. Okay, and when we think about our BODMAS, if you remember BODMAS, the O is powers, which is the powers here, so we've got to do that first. We've got 5 squared, 5 times by itself, so that's 25. We've got 4 times 25 minus 5 times 4. Do the timesing. We've got 100 minus 20, and finish off. There you go, 80. And so on we go to the last one. Here we go. So again, first job is chuck in the numbers. So there we go, A times B, 3 times 4. B times C here, so we've got 7 times 4 times 2. And the last bit, 5 times A times C, 5 times A, which is 3, C, which is 2. Okay, so now we're thinking again about our BODMAS, and you can see we've got a whole bunch of timesing here to do, and there, and then we're going to do that before we do the adding or the subtracting. So let's do the timesing. So 3 times 4 is 12, 7 times 4 times 2, oh, come on, which is 56, and that one there, which is 5 times 3 times 2, that's 30. So put all those in, so we've got 12 plus 56 minus 30. And so now we've just got to sort out that sum. 12 plus 56 is 68. Take off the 30, and we end up with 38.